Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Yeah, today we want to discuss about the atomic molecular physics CSIR and GATE exam strategy and paper pattern, old question solutions we have to take. Already I told in mathematical methods of physics, I segregated in 10 parts. In classical mechanics also I segregated in 10 parts, CSIR and GATE syllabus. Similarly, I segregated in electromagnetic theory, thermodynamics and statistical physics, condensed matter physics, quantum mechanics. Now we are coming into the atomic and molecular physics. All introductory syllabus I am giving you. Old questions also for each and every area one question I have to taken and I uploaded in YouTube. If you like my teaching, if you really interested to write the CSIR examination, so please download my app, that is Quantum Online Academy app from Play Store, right? And purchase the course. The course is available now, right? That course is available, Quantum Online Academy app. Go to the Google Play Store and download the app and you purchase that app. You listen my classes. After some time, maybe this month 18th onwards, I have to start regular live classes. I will start. All introductory classes will be available on the site. In app also freely you have to listen the classes in free content only. Clear? Please share and subscribe to your friends. Those people will get the benefited. Whatever the videos I will upload in YouTube, you will get the notification. You enter the bell button also, right? Then you listen. Whatever the concepts I am giving, those concepts will help in your competitive exam. Not only in your competitive exam, you should enhance scientifically and personally also you have to enhance in physics side. Now we have to discuss about the atomic and molecular physics. Syllabus, exam pattern, solutions of some old questions, not all old questions, some old questions. Already I told you, CSIR two varieties of syllabus is there, but three papers. One paper is condensed matter physics, that is only for 15 marks. Only advanced syllabus is there. There is no core syllabus. Now, atomic and molecular physics. In atomic and molecular physics also, in CSIR examination, only 3 questions will come. Only 3 questions. One question from atomic physics, one question from molecular physics, one question from lasers. Only 3 questions we will get from atomic molecular physics. Those questions belongs to 5 marks questions only. What is the weightage in CSIR examination from atomic and molecular physics? Only 15 marks weightage. Please concentrate. These 15 marks also easily you have to get. Concepts are very easy. Now you have to see here. Only CSIR part B, that is advanced one only. That is advanced only. How many questions you will get? Only 5 questions. 5 marks question. That is 3. Only 15 marks. Total how many marks? 15 marks you will get in atomic and molecular physics. What is that syllabus? You have to see here. First, atomic and molecular physics, there quantum states of an electron, quantum states of an electron in an atom. This is very, very easy. Quantum states of an electron in an atom. Our principal quantum number, azimuthal quantum number, and spin quantum number, magnetic quantum number, total quantum number, all these things we have to learn from here. Apart from that, you have to learn the models, Bohr atomic model, Rutherford atomic model, Sommerfeld atomic model, J.J. Thomson atomic model, vector atomic model, such type of all atomic models also we have to learn. Apart from that, we have to learn the finite mass correction, nuclear correction, all those things we have to learn from here only. Quantum states of an electron in an atom. There we have to learn about the electron spin that was introduced by Uhlenbeck and Goudsmit. A spectrum of helium atom, this is the helium atom, and alkali atoms. Whatever the 1s1 state electron configuration atoms, we call it as a alkali atoms. Alkali atoms, sodium, rubidium, cesium, francium, those atoms are there, no? The spectrum of helium atom and the alkali atom. That is very, very important. The relativistic correction for energy levels of hydrogen atom, relativistic correction, we have to approach the relativistic way. Hyperfine structure means nucleus also takes place in the structure, and isotopic effect, isotopic shift, width of the spectrum lines, LS and JJ coupling schemes, Zeeman effect, Paschen-Bach effect, Stark effect, electron spin resonance, ESR, electron spin resonance, nuclear magnetic resonance, NMR, chemical shift, Frank-Condon principle, Born-Oppenheimer approximation, electronic rotational vibrational energy, and Raman spectrum of diatomic molecules, selection rules, lasers, spontaneous and stimulated emission, Einstein coefficients, optical pumping, population inversion, rate equation, modes of resonators, and coherence level. Entire the topic, only 3 areas are there. What are the areas? One area is atomic physics. One area is atomic physics. This is the first area. The second area is molecular physics. Molecular physics. Molecular physics. The third area is lasers. The third area is lasers. Only 3 areas are there. From each and every area, 5 marks you will get in CSIR examination. Each and every area, 1 question only you will get. If you have to read entire the paper, you will get in CSIR only 3 questions. Only 3 questions from atomic molecular physics. Please remember, you won't get more than that. Clear? So this paper also very, very important. 15 marks weightage is there. Already I told so many times I am introducing this CSIR exam pattern. This exam pattern is 3 sections are there. Section A, Section B, Section C. Section A belongs to the general aptitude. General aptitude with emphasis on logical reasoning, graphical analysis, analytical and number ability, quantitative comparison, series formation and puzzles. Okay, this is part A. How many questions you are getting in the exam? 20 questions. How many questions you have to attempt? 15 questions you have to attempt out of 20. 5 questions are grace questions are there. Each and every question carry 2 marks. Each and every wrong question you may lose 0.5 marks. 1/4 negative is there. This is the part A. But part A, there is no atomic and molecular physics. Part A belongs to the general aptitude. Part B, this is from physics, but atomic molecular physics, there is no part B. Total 25 questions you will get. 20 questions you have to attempt. Each and every question for part B, you will get 3.5 marks. Each and every wrong question, you may lose 0.875 marks. Clear? Now that is the part B. In part B, we won't get from atomic molecular physics. Only part C questions we are getting. How many questions are there? 30 questions you will get in part C. Out of 30 questions, 3 questions from atomic molecular physics. Out of these 3 questions also 5 marks questions only. 20 questions you able to do in this area. Each and every question carry 5 marks. Each and every wrong question you may lose 1.25 marks. Total physics questions 55, whether it may be CSIR, whether it may be GATE examination, you will get only 55 questions from physics. Rest of the questions will come from general aptitude only. This is very, very important. Total 200 marks are there. This is the CSIR exam pattern. Clear? Now we will see the GATE. What is the GATE? The GATE is section 6th paper. This is atomic and molecular physics. In atomic and molecular physics, now you have to see spectra of one and many electron atoms. If it is one electron atom, that is a single electron atom, alkali spectra. Alkali spectra. Alkali spectra means that is the alkali atoms spectrum. We call it as a alkali spectrum. Now, many electrons atom. Many electron atom means maybe 2 electron. If it is 2 electron, we call it as a alkaline earth metals. Or helium spectrum. We call it as a helium spectrum, like that. Many electron, if you have to take the lithium and whatever the benzene, you have to take it as a zinc, you have to take as a iron, like that material also we have to exhibit. Many electron atom spectrum also we have to take from this. Next, spin orbit interaction. This one is very, very important. This spin orbit interaction, we call it as a quantum mechanical concept. Here we have to learn from this. LS coupling, JJ couplings, fine and hyperfine structure. What is the fine structure? That is spin orbit coupling. We call it a spin orbit interaction. Due to the spin orbit interaction, we will get the fine structure. That is a LS coupling only. Hyperfine structure, instead of spin orbit, we are considering a nucleus also. Here nucleus also takes place major role. Such type of nuclear spin also we have to take from this. That's why we call it as a hyperfine structure is there. Zeeman effect there also is there. Stark effect there also is there. Electrical dipole transition there also is there. Selection rules, every effect there is a selection rule is there. Rotational and vibrational spectra of diatomic molecules, electronic transitions in a diatomic molecule, Frank-Condon principle, Raman effect, EPR, electron paramagnetic resonance, NMR, nuclear magnetic resonance, ESR, electron spin resonance, X-ray spectra. These spectras there also is there in except EPR. Lasers, Einstein coefficients, population inversion, 2 and 3 level system. In GATE exam also, some topics not covered in CSIR, some topics covered in GATE. Suppose you have to see EPR spectrum. EPR spectrum is not mentioned in CSIR syllabus. In GATE syllabus, they are mentioning. Clear? EPR spectrum is mentioning in GATE syllabus. Whatever the theory is there, so those entire theory, except that entire theory is there. Except entire theory is there in CSIR and GATE, that is atomic molecular physics. Very, very important. How the exam pattern in atomic molecular physics for GATE examination. Here 2 sections are there. In section A, that is general aptitude section A, total 15 marks you will get from section A. 1 to 5 question number 1 to question number 5, you can get only 1 mark. Each and every question 1 mark. Question number 6 to 10, you will get 2 marks questions are there. 2 marks question number 6 to 10, 1 mark question number 1 to 5. If you have to see the physics, this is the second section. Second section is the physics. Total 3 varieties of questions are there. One is multiple choice question. The second one is multiple selected question. The third one is numerical answer type question. Right? Here total how many marks you will get, Nana? 85 marks you have to get from physics in GATE examination. Question number 11 to 35, you can carry 1 mark for each question. Question number 36 to 65, you can carry 2 marks. 2 marks for question number 36 to 65. Here you have to see multiple choice questions, multiple select questions, numerical answer type questions are there. In multiple choice question, instead of A, B, C, D, you have to pick up one, whether it may be A or whether it may be B or whether it may be C or whether it may be D. Multiple selected question, instead of A, B, C, sometimes A is correct, sometimes B is correct, sometimes C also correct. What are the answers are correct? Those answers you have to select. That is a multiple select question. Numerical answer type question. What is the numerical answer type question? There is one bracket they will give. So you have to enter the value, and that the here numerical answer type question, there is no negative. No negative marking for a numerical answer type questions. Please remember, this is very, very important. This one is GATE exam pattern. Clear? Here also 55 questions you are getting from physics side only. For 85 marks from physics, 15 marks from general aptitude. Total 100 marks paper. This one is a total 100 marks paper. In CSIR is total 200 marks paper. Clear? Right. Now we will go for reference books. Now we know the syllabus. According to the syllabus, what type of books are there to read all these things? Which type of books we have to refer? This is very, very fundamental thing. Clear? Those books will help you. All the syllabus will cover you. Right? If you want to take these books will help the atomic molecular physics expert in you. Now you have to see Atomic and Molecular Physics Raj Kumar. This book is very, very nice. You have to take and keep with you. Raj Kumar is very nice book. Introduction to Atomic Spectra, A Light and White. This book is very nice book. This one also you have to take. Fundamentals of Molecular Spectroscopy. That book is Benwell, Align and McCash. The Benwell book is very, very nice book. Atomic, Molecular and Optical Physics, Ken. This book also nice. Handbook of Atomic, Molecular and Optical Physics. This book is a very, very nice book. All the areas will cover. Atomic physics, molecular physics and laser part also will cover, because that is belongs to the optical physics. Springer Handbook of Atomic, Molecular and Optical Physics. This book also very, very nice. Gordon W.F. Drake edited book. An Introduction to the Molecular Spectra, Ranveer C. Johnson. These 7 books, very, very important books. You have to take any one book. That book is Atomic and Molecular Physics, Raj Kumar. Whatever the starting I wrote now, that book is very, very important book. If you have to buy and keep with you, you will get some more idea about the atomic and molecular physics. These are the syllabus. Now I mean informing you small information. CSIR and GATE batch will start from 7th January 2024 onwards. Maybe tomorrow onwards we have to start this one. Now we shifted this one. This one I'm shifting live come recording 18th January 2024 onwards. 18th January 2024 onwards, after Sankranti, after Pongal, we have to start this one. Live plus recording classes. Timings is 6 AM to 8 AM, daily 2 hours. 1.5 hours I will teach and half an hour I will give the practice questions. You have to practice it and you have to tell. So daily 2 hours work we have to do. Okay, from Monday to Saturday. Sunday you have to take the leisure time, and Monday you have to write the exam. Monday you have to write the exam. Throughout the year procedure is there. 1 year validity course is 1 year validity. Course duration also 1 year. Clear? Course duration is 1 year. 1 year duration is there. course fees, everything you have to see in the app. You have to purchase the app if you really likes. If you really want to write, if you want to really crack the CSIR examination, definitely you have to take this course. This course is help you to crack the CSIR GATE, whatever exam is there, whether it may be DL, JL or any technical exams, any physics exam, just or TF or any exam you have to take from physics side, those exams you can crack by using this course, right? This course is teacher is me only one single teacher will teach all the papers. So that's why we have to take throughout the year we have to take that much of time. Go to the Google Play Store and download the app, Quantum Online Academy app. From that app you have to purchase the course. So what is the phone numbers? 9908437460. This is my personal number. Now my institute number is 63032633668. You can call and you can negotiate also, right? If you really need it, you have to negotiate. Otherwise, you have to pay, because we have to maintain to such type of quantity, such type of quality. We need the money also, right? Now we have to see how I am segregating entire the syllabus. If you have to see, you will get the afraid about syllabus. This much of syllabus is there. Only 3 questions they will ask. Why should I write? Why should I study all these questions? People will think like this. That's why we decided, I segregated in 10 parts each and every paper. Whether it may be mathematical, whether it may be classical, whether it may be electromagnetic theory, quantum mechanics, electronics, all the papers I segregated 10 parts. 10 questions I am giving to you, right? 10 solutions I am giving to you. These are all my 9 demos. You listen my 9 demos. You decide whether I may join in this course or not, whether you may like, you may not like, you have to see. But even though if you like, you may not like, if you join or you may not join, you subscribe my YouTube channel. That will help you, because so many physics concepts I will upload in YouTube channel. Those things will help you. You share my YouTube channel to others also. Clear? Now you have to see. I segregated 10 parts. First, quantum states of electron in an atom. How I am segregating? Quantum states of electron in an atom. You may get in CSIR 5 marks only. In GATE 1 mark probability is there. Spectrum of helium and alkali atoms. Spectrum of helium and alkali atoms. You may get 5 marks only. Whether question will come in any area, you will get 5 marks only. That is 5 marks. In GATE 2 marks is there. Fine structure, hyperfine structure, coupling schemes. That is 5 marks. And 2 marks in GATE examination. Zeeman effect, Fashionback effect and Stark effect. You are getting a 5 marks and 2 marks in GATE exam. ESR spectrum, NMR spectrum, X-ray and EPR also you have to take from here. All the spectras I wrote in this. Any spectra you are getting, whether you get question that is 5 marks question or 1 mark in GATE examination. Molecular spectroscopy. Molecular spectra are 3 varieties are there. Electronic spectrum, vibrational spectra, rotational spectra. Electronic, vibrational, rotational spectra. Any molecular spectra you have to take. You may get 5 marks in CSIR, 1 mark in GATE. Whether question may come any area, that is 5 marks only in CSIR. Raman spectrum, Frank Condon principle, Born-Oppenheimer approximation, that is 5 marks in CSIR, 1 mark in GATE. Introduction of lasers. Introduction of lasers means there is a emission, spontaneous emission, stimulated emission, absorption, how we have to write the Einstein coefficients, all those things are there now. That is the laser. 5 marks you have to get, 2 marks in GATE examination. Rate equations. From the rate equations, you have to get 5 marks in CSIR and 1 mark in GATE examination.
laser modes of resonators and coherence length. Laser modes of resonators and coherence length. You will get the 5 marks in CSIR, 2 marks in GATE. I segregated into 10 parts. Total 3 areas are there. One area is atomic physics. One area is atomic physics. Somewhat atomic physics is content is more is there, right? Another area is molecular physics. Another area is molecular physics, right? The third area is optical physics, that is a laser part. In optical physics, entire thing is not there. Laser part is there. I segregated, you have to see. Quantum states of an electron in an atom. That is the first one. Spectra of helium and alkali atoms. In GATE, CSIR, both are there in the syllabus. Fine structure, hyperfine structure, coupling schemes. Coupling schemes means JJ coupling, LS coupling, all the coupling schemes are there. That is in both CSIR and GATE also is there. Zeeman effect, Passion-Bach effect and Stark effect. In both areas, all the effects I wrote there. ESR, NMR, X-ray spectra and EPR spectrum. These spectra you may get in both areas also is there. Molecular spectroscopy. In molecular spectroscopy, electronic spectra, vibrational spectra, rotational spectra, in both areas also is there. Raman spectra, Frank-Condon principle, Born-Oppenheimer approximation, this is also is there. Introduction of lasers, laser rate equations, laser modes of resonators and coherence length. These 10 parts I divided. You also like this, you want to follow easy, whether it may be easy, you will get the pakka questions also. Sometimes whatever the area I took, you will get the same area I told now. So that area question came, you are benefited, right? So that's why you have to see. Each and every area I took one question. I am explaining. These questions already came previously in CSIR or GATE examination. Now you have to see here. First question I have to take from which area? Quantum states of electron in an atom. Now you have to see. Given that the ground state energy of the hydrogen atom is minus 13.6 electron volt. The ground state energy of the positronium atom. Which atom it is, Nana? Positronium atom, which is a bound state of electron and positron. Positronium atom means, what is the positronium atom? This question was asked December 2011 CSIR. December 2011 CSIR question paper got this question. What is a positronium atom? First you listen. What is the positronium atom? Positronium atom means, positronium atom means, which one we have to take? Positronium atom. What is the positronium atom? First you learn. First you have to take, in the nucleus proton is there. This proton was replaced by positron. This proton was replaced by positron. In a orbit, one electron is there. Positron and electron. Electron and positron combination atom, we call it as a positronium atom. This atom, which one it is? See in the center, which one is there? Positron is there. In the center, positron is there. In the orbit, which one is there, Nana? Electron is there. In the orbit, electron is there. In the center, positron is there. The combination of positron and electron, we call it as a positronium atom. Suppose if it is combined, which one we have to take, Nana? We are calculating a reduced mass. We are calculating the reduced mass. This reduced mass is equal to M1 M2 is divided by M1 plus M2. M1 plus M2. What is the M1? Mass of the positronium. What is M2? Mass of the electron. Mass of the positronium is equal to mass of the electron is equal to, we have to take it as a m, mass of the electron only. Mass of the electron only. You have to substitute here. Mu is equal to mass of the electron into mass of the electron is divided by mass of the electron plus mass of the electron. Which one we have to get? Mass of the electron square is divided by 2me. Me get cancelled. Therefore, reduced mass is equal to mass of the electron is divided by 2. Mass of the electron is divided by 2. The positronium atom reduced mass is equal to mass of the electron is divided by 2. We got it. Now, which one we want to calculate, Nana? We want to calculate the energy of the positronium. We want to calculate. How we have to calculate? The energy, if reduced mass will change, the energy En dash is equal to, there is a formula is there, En into mu by mass of the electron. What is the mu? Reduced mass. Now you have to substitute here. En into mu is equal to mass of the electron is divided by 2 into mass of the electron. Mass of the electron get cancelled. Therefore, which one we have to get, Nana? En is divided by 2, which is equal to mass energy of the positronium is equal. Already they gave En is equal to, this one is a hydrogen atom ground state energy. Hydrogen atom ground state energy. Which energy it is? This one is a hydrogen atom ground state energy. How much they are giving? En is equal to minus 13.6 electron volt. Now you have to substitute. What is the positronium ground state energy? They are asking. The positronium ground state energy En dash is equal to En minus 13.6 electron volt is divided by 2. 2 1 ja, 2 6.8 ja. So therefore, how much you are getting? 6.8 electron volt we are getting. What is this? This is the ground state energy of positronium atom. Ground state energy of positronium atom. This is very, very important. Once again, you have to listen how I am doing. So, this is a finite mass correction formula. From the finite mass correction formula, they are asking this question December 2011 in CSIR time. What they are giving, once you have to see, given that the ground state energy of the hydrogen atom is they are giving, that data you have to take. Then the ground state energy of the positronium atom they are asking. What is a positronium? First, positronium. What is a positronium? You come to know. What is the positronium? It is a combination of positron and electron atom. Then you calculate the reduced mass. Then you apply the finite mass correction formula. What is the finite mass correction formula? En dash is equal to En into mu by me. Therefore, you calculate, you substitute the reduced mass. Then from this, you will get the ground state energy of the positronium. What is the ground state energy of the positronium? Minus 6.8 electron volt. Clear? This is very, very important. Not only single time, many times this question came. 2-3 times CSIR people only they are asking this question. Just you have to remember what is the ground state energy of a positronium atom. Just En by 2 you have to remember. Just En by 2 you remember, you can get the answer immediately. What is the answer? Now you have to see option B is correct. Option B is minus 6.8 electron volt. Very simple. How many marks you will get? 5 marks you will get. Whether question will come from atomic and molecular physics, only 3 questions you will see, that is part C in CSIR pattern. In part C, 3 questions also, easy questions only. Clear? Now you have to see the second one. Second one, which one we have to take, Nana? What is the area of the second area? I segregated spectra of helium or alkali atoms spectra. How we have to take the question once you have to see. The ratio of intensity of the D1 and D2 lines of sodium at high temperature. What is the sodium? Sodium is a single electron atom. Sodium atomic number is 11. Sodium atomic number is 11. If you have to write the electron configuration, 1s2, 2s2, 2p6, 3s1. 1s2, 2s2, 2p6, 3s1. First you have to energize it. So what will happen now? So this 2p6 electron will goes to here, right? P6. Otherwise this electron will goes to 3p state. This electron will goes to 3p state. These are the completely filled. If you won't participate anything, this electron ready to come to the ground state. Ready to come to ground state, there is a transition is there. Which transition? That is 3p to 3s transition. If it is a p, what will happen? First s we have to see. If you have to take a 3s, you write L is equal to 0, S is equal to 1 by 2, J is equal to 0 plus or minus 1 by 2 is equal to 1 by 2 is there. Our state will become 2s plus 1 is equal to, we have to write it as a 2s 1 by 2. This is the state of representation of 3s state. Now we have to see, this is a 3p state. Which state it is? 3p state. L is equal to 1. If P, L is equal to 1. S already we know. S is equal to 1 by 2. J is equal to, if you have to add, you will get the 3 by 2. You subtract, you will get the 1 by 2. Therefore, how many states it will come na? 2S, 2P 1 by 2 and 2P 3 by 2 you are getting. There is a transition is there. That is 2p 1 by 2 to 2s 1 by 2, one transition. That transition we call it as a D1 transition. There one more transition is there. What is the transition, Anna? 2p 3 by 2 to 2s 1 by 2 transition is there. That transition we call it as a D2 transition. What they are asking? What is the intensity lines? Intensity lines ratio they are asking. Intensity of D1 is to intensity of D2 they are asking. Intensity of D1 is to intensity of D2 they are asking. How we have to calculate? Once you have to see. First D1 transition you have to see. What is the D1 transition, Anna? 2p 1 by 2 to 2s 1 by 2. This is the transition of the D1 transition. What is the D2 transition? D2 transition is 2p 3 by 2 to 2s 1 by 2. This is a D2 transition. What is the intensity you have to see? Intensity is proportional to 2j plus 1. 2j plus 1 means 2j d1 plus 1 is to 2j d2 plus 1. 2j g1 plus is to 2j d2 plus 1. J, what is the j here? 1 by 2 is there. That one you have to take. Initial j you have to take 1 by 2 plus 1. 2 get cancelled is 2. 2 into, what is the here? J is there? 3 by 2. Into 3 by 2 plus 1. 2 get cancelled. 1 plus 1 is equal to 2. 3 plus 1 is equal to 4. 2 1 ja, 2 2 ja. How much you are getting, Nana? 1 is to 2 you are getting. What is the intensity ratio of D1 is to D2? This question so many times. At least 10 times they are asking in CSIR. What is the sodium D1 D2 intensity ratio is equal to 1 is to 2. 1 is to 2. What is the answer? That answer is option is equal to D. This is very, very important. Like this we have to do. Just simply you have to see the ratio of intensity of the D1 and D2 lines of sodium at high temperature. When they are asking December 2011 CSIR exam paper, this question is there. That answer is 1:2. Clear? How we are telling? First you have to take the sodium atom. This is a alkali atom. Which atom it is? Alkali atom. Because in the last orbit, how many electrons are there? 1 electrons are there. 1 electron is there. Suppose if you have to give the energy, what will happen? This S1 electron will go to the 3p state. Next state it will go. But how much time it should stay? Within the 10 to the power of minus 8 seconds, this 3p electron come to 3s. So that time there is a transition is there. That transition we call it as a two varieties of transitions are there. That is the fine structure. That one is how many lines are there? 2 lines are there. One line is D1 line. Another line is D2 line. That's why if you have to take in your laboratory, sodium lamp you are taking now, there you are taking the wavelengths also 2 wavelengths. One is 5890 angstroms. One more is 5896 angstroms is there. In your laboratory you are averaging that 5893 angstroms you are taking. But 2 lines are there. That is not monochromatic exactly, because there is a 2 transitions are there according to the fine structure. If you go to the hyperfine structure, you will get the 10 transitions also, but not now. According to this question, your option is 1:2. Now I am coming into the third one. What is the third one? Hyperfine structure I have to take. Once you have to see. This is the fine structure, hyperfine structure, coupling schemes are there. Those entire the thing will cover. If the hyper interaction of an atom is given by, there is a Hamiltonian they are giving. What is the Hamiltonian? That interaction energy, we call it as a Hamiltonian. Interaction energy between whom and whom? Between the proton and between the electron, there is a interaction energy is there. They are giving the interaction energy H is equal to A into Se dot Sp. What is the Se and Sp? Se is electron spin, Sp is the proton spins respectively. The splitting between they are asking the splitting between 3s1 state and which one they are asking? 1s0 state. 3s1 state and 1s0 state splitting they are asking. First you follow one rule. How we have to follow? First 2 atoms are there. 2 atoms. Which atoms? One is electron, another one is the proton. These 2 electron, one electron is there, another one is the proton is there. Therefore, the total spin is equal to, we have to write total spin is equal to Se plus Sp. Now you square on both sides. First you take sum of the electron and proton spins. The resultant spin is equal to S. You square it. S square is equal to Se square plus Sp square plus 2 into Se dot Sp. This is the interaction term. Which one they are giving? Interaction term they are giving. That one you have to find out. You bring this side S square minus Se square minus Sp square is equal to 2 into Se dot Sp. Se dot Sp is equal to 1 by 2 into S square minus Se square minus Sp square. You substitute this value. You substitute this value. Where you have to substitute? In H you have to substitute. How much you have to get, Nana? H is equal to A by 2 into S square minus Se square minus Sp square. Now we have to get one equation. We have to get one equation. H value we are getting. How we have to calculate? Again you have to see. H is equal to, we are finding, H is equal to A by 2 into S square minus Se square minus Sp square. Now we have to calculate the Se and Sp. Se is equal to square is equal to Sp square is equal to S into S plus 1 into H cut square. Whether you have to take the electron spin or proton spin, that value is the same. That's why you have to write 1 by 2 plus 1 into H cut square. 1 by 2 plus 1 is equal to 3 by 2. 3 by 2 into 1 by 2 is equal to 3 by 4 H cut square, which is equal to Nana Se square is equal to Sp square is equal 3 by 4 H cut square. Now again you have to substitute, instead of H is equal to A by 2 into S square minus Se square. What should I write? 3 by 4 H cut square. Sp square is equal to also 3 by 4 H cut square I am writing. Now you have to add T by 4 minus 3 by 4. H is equal to A by 2 into S square minus 3 by 2 H cut square is there. 3 by 2 H cut square is there. Now we have to calculate the S value. How many states are there? These two states are there. One state is 3s1, one more state is 1s0. 3s1 we have to write. For 3s1, you have to calculate for 3s1. 2s plus 1 multiplicity is equal to 3. 2s is equal to 3 minus 1. 2s is equal to 2. S is equal to 1 we are getting. But we have to know S square value. S square is equal to S into S plus 1 into H cut square. Therefore, you have to substitute 1 into 1 plus 1 into H cut square is equal to 2H cut square, which is equal to S square is equal to. For whom? For S square plus 3S1 state. Now you have to see for which one we have to take, Nana? We have to take it as a 1S0. 1S0 state we have to take. 1S0. 1S0, what is the multiplicity? 2S plus 1 is equal to 1. 2S is equal to 1 minus 1 is equal to 0. S is equal to 0 by 2 is equal to 0. Therefore, S square is equal to S into S plus 1 into H cut square. Therefore, what we have to write? So, we have to write it 0 into 0 plus 1 into H cut square. 0 into anything is equal to 0. S square is equal to 0. For which state? 1S0 state is equal to. Now you calculate. S square value how to calculate? S square value you substitute, that is for H1. H1 for warm. H1 for 3S1 state. That is equal to, you have to substitute A by 2 into, what is the S square, Nana? 2H cut square. 2H cut square minus 3 by 2 H cut square. 3 by 2 H cut square. Therefore, A by 2 into 2 2 ja 4, 4 minus 3 is equal to H cut square is divided by 2. We are getting H cut square is divided by 2. Therefore, how much we are getting, Nana? A H cut square is divided by 4 we are getting. For which state? 3S1 state. Now we have to see H2 is equal to, for 1S0 state. Which state it is? 1S0 state you have to take. A by 2 into S square is equal to, how much we are getting here? 0 minus 3 by 2 H cut square is there. 3 by 2 H cut square. Therefore, minus 3A by 4 into H cut square. Minus 3A by 4 into H cut square. Now we have to calculate the splitting between H1 and H2. Delta H we have to calculate. How we have to calculate delta H? Once you have to see, delta H is equal to H1 minus H2. H1 minus H2. H1 is equal to how much we are getting? A H cut square by 4. A H cut square is divided by 4 minus of H2 is equal to how much we are getting? H2 is equal to minus 3A by 4 into H cut square. Minus 3A by 4 into H cut square. Now you have to minus into minus plus A H cut square by 4 plus 3A by 4 into H cut square. Now you have to see A H cut square, you have to take the common 1 by 4 plus 3 by 4. You take the LCM A H cut square into 4, you have to take the LCM 1 plus 3. 4 get cancelled. Therefore, the splitting between these two spectral lines is equal to A H cut square. How simple it is. Just calculation is bigger. But if you know the concept, if you know how to apply the concept, then easy to get this question. Easily you will get the 5 marks in CSIR examination. What is your option? Your option B is correct. A H cut square you are getting. Option B is correct. This is the coupling schemes. From coupling schemes I took this question. Here entire thing is covered. Proton and electron can take interaction. There is an energy is there. That energy is a potential energy. That energy itself Hamiltonian, right? From that we have to calculate the splitting between these two states is equal to AH square. AH cut square. When they are giving this in question December 2013 CSIR exam pattern, exam paper, this question is there. How simple it is. Just simple multiplication and cancelling is there. You will get the option. Now the fourth area. What is the fourth area? All the effects are there. Stark effect, Zeeman effect, and one more effect is there. So which effect? That is the Raman effect. Any effect question you may get in your competitive exam. From that you have to see a normal Zeeman effect experiment using a magnetic field. Magnetic field they are using. In the presence of the magnetic field, how much magnetic field is there? 0.3 Tesla. The splitting between the components wavelength they are giving, lambda is equal to 660 nanometer, 10 to the power of minus 9 meter. What they are asking? The splitting between the delta lambda. This is the Zeeman shift in the presence of a magnetic field they are asking. What is the formula? EB into lambda square is divided by 4 pi MC. This is the your formula. From this formula you have to substitute all the values. E is the spin of the electron value, 1.6 into 10 to the power of minus 19 joules. B is equal to 0.3 Tesla. Lambda is equal to 660 into 10 to the power of minus 9 whole square is divided by 4 into 5 means 3.14. M is, this is the electron mass, 9.1 into 10 to the power of minus 31 kg. This one is a light velocity, 3 into 10 to the power of 8 meter per second. You calculate this, you will get this option. This option is equal to 6 into 10 to the power of minus 12 meters you are getting. Therefore, 6 picometers you are getting the option. Which option is correct? 6 picometer. 6 picometer you are getting the value. It one little bit difficult. We have to calculate that one. Entire the thing. You have to take all the values 10 to the power of. So you have to take an upside and then you have to see how much power is coming. From that power you calculate this one. Very simple. Very simple. If you know the Zeeman shift in terms of the wavelength, Zeeman shift in terms of the wavelength. This one, which one it is? Classical Zeeman shift. Zeeman shift. Please remember this formula. This is very, very important formula. This is the Zeeman shift. So many times your competitive people asking based on this formula questions are there. Clear? This is very, very important. Now we are going into the fifth area. What is the fifth area? You have to see. Match the phrases in group 1 and group 2. Identity the correct option. This question came from 2015. This question, which area? This is the EPR spectra, ESR spectrum, NMR spectrum and vibrational spectrum, electronic spectrum. These molecular spectra. This question came from molecular spectrum. Once you listen, here electron spin resonance, that is the ESR. Electron spin resonance is achieved because of which one? Microwave range frequency. Which frequency it is? Microwave range frequency. That frequency we call it as a microwave frequency. Which one that is? You have to remember electron spin resonance. This is the first one. Now you have to see first one, the third option is correct. Clear? Now the second one you have to take nuclear magnetic resonance, that is NMR. NMR is achieved when this achieved in radio frequency or radio frequency range. NMR is achieved by the radio frequency range. Now you have to see third one. What is the third one? Transition between the vibrational states, vibrational energy levels. This vibrational energy level transition can happen. Where can happen? This is a far infrared IR region. Far infrared region. This one is the radio one. This one is one. This far infrared region. Rest of the thing you have to see. The fourth one is electronic transition. Electronic transition can take place. Electronic transition can take place in visible range, visible region. Electronic transition can take place where it is takes place in visible region. That is number 2. Now you have to see. So the first one P, which one it is correct? Third one is correct. The second one is correct. 1 is correct. The third one you have to see. Fourth is correct. The fourth one you have to see. The second one is correct. Fourth option is correct according to this. While we are teaching electronic spectrum, vibrational spectrum, rotational spectrum and ESR and NMR, EPR, all the things whenever we are learning, that time how much frequency range, within the what frequency range those things are executing, those things we learn. We are taking the match the following. This option is very, very important. Like this only they are asking the questions all these days. This is very, very important. This area from spectra, ESR, NMR, X-ray, EPR. From those spectrums we are asking this type of question. This question is question number 5. Easily we will get the 5 marks. In GATE examination they are asking in 2015. Now you have to see. Express for the second overtone frequency in the vibrational absorption spectrum. Vibrational absorption spectrum. Which one they are asking? In a vibrational absorption spectrum. Vibrational absorption spectrum. This is very, very important question. So many times they are asking the question. This type of question. In vibrational absorption spectrum, you have to see how the spectrum will be. If it is mu is equal to 0 level, that is the vibrational level. Mu is equal to 1 energy level. You have to take a mu is equal to 2 energy level. You have to take mu is equal to 3 energy level. From 0 to 1 transition, we call it as a fundamental series. Which series it is? It is the fundamental series. Fundamental series. From 0 to 2 transition, we call it as a first overtone. First overtone. Next, you have to see from 0 to 3 transition, we call it as a second overtone. Second overtone. 0 to 1 transition, we call it as a fundamental series. 0 to 2 transition, we call it as a first overtone. 0 to 3 transition, we call it as a second overtone. Now, what is the selection rule? Delta nu is equal to plus or minus 1, plus or minus 2, plus or minus 3 and so on. This is the selection rule of a vibrational absorption spectrum. What they are asking now, you have to see. The expression for the second overtone. They are asking about the second overtone. What is the second overtone? And mu is equal to 0 to mu is equal to 3. We call it as this is a second overtone, correct? Second overtone. Second overtone. What they are asking, you have to see. A diatomic molecule in terms of the harmonic frequency omega e, and harmonicity constant is xe. Harmonic frequency, they are giving omega e is a harmonic frequency. Anharmonic constant is xe. What is that second overtone frequency they are asking. Second overtone frequency, they are asking about the second overtone frequency. What is the second overtone frequency they are asking? See, second overtone frequency. How we have to calculate once you have to see. The spectral term of vibrational absorption spectra is given by that formula I am giving. Once you have to see G of nu is equal to G of nu is equal to G of nu dash minus G of nu is equal to, one formula is there, that formula I am giving. G of nu is equal to nu plus 1 by 2 into omega e. This is the fundamental harmonic velocity, harmonic velocity minus mu plus 1 by 2 whole square into omega e xe. This is the formula. Which one it is? This formula is G of nu is equal to mu plus 1 by 2 into omega e. This is the fundamental angular velocity. Mu plus 1 by 2 whole square into omega e xe. What is our transition? Our transition is mu is equal to 3 to second overtone. Mu is equal to 0. Suppose you have to take a mu dash is mu's double dash if you have to consider. This is the transition. Which transition it is? Second overtone transition. Second overtone transition is mu dash is equal to 3 to mu double dash is equal to 0. First you have to substitute. How we have to get? Therefore, mu bar is equal to G of mu dash minus G of mu double dash. Now you can substitute the value. G of mu dash you have to substitute. How you have to get nana? 3 plus 1 by 2 into omega e minus 3 plus 1 by 2 whole square into omega e into xe minus, so you have to take here. So which one we have to write? Mu double dash is equal to 0. 0 plus 1 by 2 into omega e minus 0 plus 1 by 2 whole square into omega e xe. Now you simplify. So 3 plus 1 by 2 is equal to 7 by 2 omega e minus 3 plus 1 by 2, 7 by 2, 7 7 ja 49 by 4 into omega e xe minus 1 by 2 omega e by 2 minus into minus plus omega e xe is divided by 4. Now you have to subtract 7 by 2 omega e you have to do here. How you have to do? Once you have to see 7 by 2 second overtone frequency. This is the second overtone frequency. Frequency of a second overtone. Second overtone frequency you have to take 7 by 2 omega e minus omega e by 2 plus minus 49 by 4 omega e xe plus which one we are getting, Nana? Omega e xe by 4 we are getting. First you take omega e common, you have to take 7 minus 1 is equal to 3. 3 by 2 is equal to 3 omega e. Minus you have to take here. So you take the common minus 49. You take common. Which one happen? You have to see 49 minus 1 by 4. You are getting 48. 48 means 4 1 ja, 4 2 ja. 12 omega e xe. Therefore, if you have to take the common 3 omega e, you have to take the common 1 minus 4 omega xe. 1 minus 4 xe you are getting. This is the frequency of second overtone. 3 omega e into 1 minus 4 xe. Once you have to check the options, which option is correct? Once you have to see the second overtone frequency is equal to option D is correct. 3 omega e into 1 minus 4 xe. 3 omega e into 1 minus 4x. This is very, very important. You may know what is the electronic vibrational energy level and rotational vibrational energy level, electronic transitional vibrational energy level, rotational and vibrational energy levels. So those spectra you come to know. Which spectrum it is? It is a vibrational absorption spectrum. From vibrational absorption spectrum, they are asking second overtone frequency. If it is, you have to take the selection rules. The selection rules are plus or minus 1, plus or minus 2, plus or minus 3 is there. According to the selection rules, we have to take the transition. The fundamental series is belongs to 0 to 1. The first overtone is belongs to the 2 to 0. The second overtone is belongs to the 3 to 0. Clear? From this, we have to calculate result is 3 omega e 1 minus 4 xe. Direct also you have to do this optional like this also you have to substitute. If you have to join, I will give one more formula how we have to calculate, how simply we have to calculate this one. We will see that one also. This is the 6th question. Now you have to see the 7th one. This one also very easy, from the molecular spectrum only we have to take. The far infrared rotational absorption, spectrum of a diatomic molecule shows equilibrium lines. First, rotational spectrum. Which one we are taking? Rotational spectrum. They are giving about the rotational spectrum. In the rotational spectrum, absorption spectrum, the energy levels, energy spacing, the line spacing between line spacing is 2 into B in rotational spectrum. What is the line spacing between the two lines? What is the distance is there? 2B is there. That 2B is equal to how much they are giving, Nana? 20 centimeter inverse. 2B is equal to 20 centimeter inverse they are giving. 2 1 ja, 2 10 ja. Therefore, B is equal to 10 centimeter inverse we are getting. What they are asking, once you have to see the position of the first Stokes line in the rotational Raman spectrum. They are taking as a rotational Raman spectrum. Once you observe the rotational Raman spectrum, Raman is our Indian scientist. He got the Nobel Prize. Very, very important. Compulsory one question they will make in any exam, any competitive exam, because he is an Indian scientist. That's why any person will make the question. What is this? First, this is the Rayleigh frequency line. Here you have to take a Stokes lines. Here you have to take anti-Stokes. First Stokes line, first Stokes line, first anti-Stokes line. How much distance is there from here to here? 6b. 6b distance is there from Rayleigh line to the first Stokes line. Next, from Rayleigh line to the first anti-Stokes line, what is the distance is there? 6b is there. Later it is 4 is there, but now you have to see 6b. What they are asking? First, from Rayleigh line to first Stokes line, what is the spacing they are asking? 6b spacing is there. Already b we found. 6 into 10 is equal to 60 centimeter inverse. This is a first Stokes line in the Raman rotational spectrum of the molecule. What is your option? Your option is C. How simple is there once you have to see. Your option is very, very important. Just simply you will get the 5 marks. Simply you will get the 5 marks. Just you have to remember rotational Raman spectral line spacing is equal to 2b and first Raman spacing is equal to 6b from the Rayleigh line. That is very, very important area. Now we will go to the next section. What is the next section you have to see? Consider a hydrogen atom undergoing 2p to 1s transition. That hydrogen from the laser we have to take hydrogen line is going the transition from, consider a hydrogen atom undergoing 2p to 1s state transition. The lifetime spontaneous emission, the spontaneous emission of the 2p state for the spontaneous emission is 1.6 nanosecond. 1.6 nanosecond. The energy difference between the level delta E is equal to h cut omega is equal to 10.2 electron volt. This is the energy level between the two states, 2p to 1s state. Assuming that the refractive index of the medium N0 is equal to 1, if you have to take the refractive index is equal to 1, the ratio of the Einstein coefficient for the stimulated and spontaneous emission, the stimulated and spontaneous emission, how much they are asking. Once you have to see here, how we have to calculate, this is very, very important, the ratio between the stimulated to spontaneous emission. There is a formula is there, Einstein stimulated emission coefficient. What is the B21? Einstein stimulated emission coefficient is divided by, what is A21? Einstein spontaneous emission coefficient. This is one is a Einstein stimulated emission coefficient. This one is a Einstein spontaneous emission coefficient. Einstein stimulated emission coefficient to Einstein spontaneous emission coefficient formula, which one they are asking, is equal to phi square, there is a formula is there, phi square c cube is divided by, h cut omega cube into n naught cube. This is the formula. Please remember, this formula is very, very important. This is the formula, Einstein spontaneous emission coefficient to Einstein stimulated emission coefficient to Einstein spontaneous emission coefficient. Now you calculate here. So how we have to calculate? You multiply with h cut square, phi square c cube is divided by h cut square into h cut omega cube n naught cube you have to take. So h cut square into h cut, so both side numerator and denominator I am multiplying with h cut square and h cut square. If it is get cancel also, h cut square into h is equal to h cut cube. How we have to do? H cut square phi square c cube is divided by h cut cube omega cube into n naught cube. Now you write the formula. How the formula you write? B21 is divided by A21 is equal to h cut square phi square c cube is divided by h cut omega whole cube into n naught cube. Now you substitute the values. What are the values? H cut is equal to 1.054 into 10 to the power of minus 34 whole square. Phi is equal to 3.14 whole square. C is equal to 3 into 10 to the power of 8 whole cube is divided by h cut omega is equal to, they are giving the value. How much value they are giving, Nana? So 10.2 electron volt. 10.2 into electron volt you have to convert it into the joules. 1.6 into 10 to the power of minus 19 whole cube. N cube is the n naught cube is equal to 1 cube. If you have to solve this one, A21, B21 is divided by A21 is equal to, if you calculate this value, you are getting how much value you are getting? 0.67 into 0.67 into 10 to the power of 12 you are getting the value. Once you have to check 0.67 into 10 to the power of 12, that option A is correct. Which one is correct? Option A is correct. This is very, very important, right? You remember the formula. This formula is very, very important formula. Einstein stimulated emission coefficient to Einstein spontaneous emission coefficient ratio. That ratio is very, very important. Clear? This is the lasers first question. 3 areas I segregated from the laser. First question is from introduction part, that is the Einstein stimulated and spontaneous emission coefficient part. Now the second part you have to see here. Consider the energy level diagram. There is an energy level diagram is there here, which corresponding to the molecular nitrogen laser. This is a molecular nitrogen laser. This one is the 3-level laser diagram. If the pump rate is R is equal to, they are giving 10 to the power of 20 atoms. The pump rate is equal to 10 to the power of 20 atoms, centimeter to the power of minus 3 second inverse. The decay routes are as shown within the tau 21 is equal to 20 nanoseconds. Tau 1 is equal to 1 microsecond. The equilibrium populations of the states 1 and 2 respectively they are asking. The equilibrium population of N2 is equal to how much? N1 is equal to how much they are asking. First you have to write the laser rate equation. This one, laser rate equations we have to write. How we have to write the laser rate equation? Once you have to see. First, I want to take the new one and then I will explain once you have to see. There is a 3 levels are there. This is the 0 energy level. This energy level is 1 energy level. This energy level is 2 energy level. Suppose if you have to give the optical pumping, electrical pumping, ionic pumping, any pump you have to pump. So that pumping rate is equal to R. Then this atom is goes to the N2 level. So that is the level 2. So this atom is ready to come to one state with what is the tau 21. If one state atom also ready to come to that state is the tau 1 state is there. Now each and every level you have to write the rate equation. How we have to write the rate equation you have to see. The rate equation for level 2. Level 2 I am writing. The rate equation for level 2. What is the rate equation for level 2? The rate of change of population of level 2 dN2 by d2 is equal to what area, from which area it is coming the atom? From the 0 level R. That one is a positive we have to take. So from level 2 there is a emission is there, spontaneous emission. That emission is N2 is divided by tau 21. Tau 21 is equal to A21 is equal to, you have to write A21 is equal to 1 by tau 21. This is the equation number 1 you have to take. This is the first rate equation for corresponding level 2. Next you have to write rate equation. We have to take a rate equation for which one we have to take, Nana? Level 1. Rate equation for level 1 you have to take. What is the rate equation for level 1? Similarly, dN1 by dt is equal to, from which side is atom is coming? N2 by tau 21. From which side is atom is going? N1 is divided by with tau 1. So tau 1 is equal to A10 is equal to tau 1 by tau 10. This is the spontaneous emission coefficient. Is the reciprocal of the time period. So the reciprocal of the time taken to that is the taken, how much time is there, that is the lifetime you have to take. Under the equilibrium condition, one thing you have to take, under equilibrium condition, which one we have to write, Nana? dN2 by dt is equal to dN1 by dt is equal to 0 under the equilibrium condition. Now you have to apply the equilibrium conditions you have to apply. First, from first equation I am applying dN2 by dt is equal to 0. 0 is equal to R minus N2 by tau 21. Now you have to bring this. R is equal to N2 by tau 21. Therefore, N2 is equal to R into tau 21. R they are giving the value 10 to the power of 20. How much value they are giving? 10 to the power of 20. Tau 21 also they are giving 20 nanosecond. 20 nano 10 to the power of minus 9. Nano means 10 to the power of minus 9 seconds. 20 nanoseconds. How I am writing? Now you have to see here 20 nanoseconds. Now you have to take which one we have to take? 20 into 10 to the power of 20 minus 9. 10 to the power of 11 it will come. But to make the option, what we have to do? 2 into 10 to the power of 12 like that I want to make it. 2 into 10 to the power of 12 like that I have to make it. So that's why you have to see here 2 into 10 to the power of 12. So this is the number of atoms in the energy level 2. Similarly, you take the equation number 1. From the equation number 1, you have to calculate the N1 value. Once you have to see. What is the equation number 1, Nana? dN2, N1 is divided by dt is equal to N2 is divided by tau 21 minus N1 is divided by tau 1, correct? This is equal to, under the equilibrium, dN1 by dt is equal to 0. N2 by tau 21 minus N1 by tau 1. Now you have to bring this value. N2 by tau 21 is equal to N1 by tau 1 is there. Which one we need? N1 we need. Therefore, N1 is equal to N2 tau 1 is divided by tau 21 is there. Now you have to see. Therefore, N1 is equal to, N2 is equal to 2 into 10 to the power of 12. Now only we calculate. Tau 1 is equal to, they are giving the option 1 microsecond. 1 micro means 1 into 10 to the power of minus 6 is divided by tau 21 is equal to, already they took the tau 21 is equal to how much? 20 into 10 to the power of minus 9. 20 into 10 to the power of minus 9. Now you subtract. So how we have to get 2 1 ja, 2 10 ja. This is 10 to the power of minus 8. 10 to the power of minus 8 goes to the 10 to the power of 12 into 10 to the power of minus 6 into 10 to the power of plus 8. Now it will goes to the 10 to the power of 2, 10 to the power of 14 you are getting. This is the N1 value. Now you see the options, how simple it is there. If you know the logic, how to write the rate equations, easily you have to find out. There is no miracle, there is no rocket science in this. Just you are getting a N2 level atoms is equal 2 into 10 to the power of 12 and N1 level atoms are 10 to the power of 14 atoms are there. It's very simple. If you know how to write the laser rate equation, if you write the laser rate equation, you will get very simple. How many marks? 5 marks you will get in CSIR. How simple it is once you have to see. In December 2012, this question they are asking. Clear? Now the last one we have to see. What is the last one? That is the coherence length and laser resonant modes. Coherence length and laser coherent. A gas laser cavity has been designed to operate it. We have to operate. There is a cavity. The fully reflected M1 mirror is there. This one is a partially reflected mirror. Such type of configuration we call it as a resonant cavity or laser cavity. This is to maintain the laser phenomena, light amplification by stimulated emission of radiation. By stimulated emission of radiation, so much of atoms are generated. So those atoms, without feedback if you have to use, so that the entire active material will collapse. So that's why we have to use this one, that is a resonant cavity. That lambda is equal to how much length we have to produce from here? Lambda is equal to 0.5 micrometer. Lambda is equal to 0.5 micrometer with a cavity length. What is the cavity length? L is equal to 1 meter cavity length. With this setup, the frequency is found to be larger than desired frequency. Frequency we are finding. How much frequency we are finding? Larger than the designed frequency. The designed frequency delta nu is equal to 100 Hz is there. The change in the effective length. Which one they are asking? The change in the effective length delta L is equal to how much they are asking. Now you have to see. Mu, there is a frequency formula is there. Mu is equal to m into C by 2L. There is a formula. What is the mu? This is the mode of the frequency. Mode of frequency. What is m? Number of longitudinal modes. What is C? C is a light velocity. Now, how we have to calculate? What is our purpose? Delta L we need to calculate. How we have to calculate once you have to see. Mu is equal to m into C by 2L. There is a principle. Mu is equal to m into C by 2L, correct? Now you have to differentiate explicitly on both sides. Delta mu is equal to m into C is the constant. So 2 also constant, you have to differentiate it minus 1 by L square into delta L you have to write. We are explicitly differentiating. Delta mu is equal to minus m into C by 2L square into delta L. But we know m. So what is the m? Number of longitudinal modes. There is a formula for a number of longitudinal modes. Mu by C into 2L. The number of longitudinal modes is equal to mu by C into 2L. If you have to take, this is the equation number 1. This is the equation number 2. Substitute the equation number 2 in equation number 1. What you have to do, Nana? substitute equation number 2 in equation number 1. What is the equation number 2? Delta mu is equal to minus m you have to substitute here, mu by c into 2l, mu by c into 2l. Next you substitute c by 2l square into delta l. Now 2 1 ja 2 1 ja get cancelled, c get cancelled, 1 l also get cancelled. Therefore delta nu is equal to minus mu into delta l is divided by l is there. What is the mu? Mu is equal to c by lambda. Therefore delta nu is equal to minus c by lambda into l into delta l. Which one we want to calculate? Delta L we want to calculate. Then you have to arrange the expression. Delta L is equal to minus lambda L is divided by C into delta nu. All the values you know, just you substitute the values, you will get the answer. What is the formula we derived? We derived the formula concerning the enhancing length formula. Delta L is equal to minus lambda L is divided by C into delta nu. Minus lambda is equal to, how much they are giving? Lambda is equal to, we know, 0.5 micrometer. Lambda is equal to 0.5 into 10 to the power of minus 6. L is equal to 1 meter. C is equal to 3 into 10 to the power of 8. Delta nu is equal to 100 Hz frequency is there. If you have to simplify, how much we are getting? Minus 0.67 into 10 to the power of minus 12 value you are getting in terms of meter. Once you have to check the options, whether option is there or not, you have to see that option is there. That option is D option. This is the from resonance normal modes and coherence length. From the that area we get the question. December 2013 CSIR time they are asking this type of question. I segregated 10 parts from 10 areas also. I gave the questions. Once you have to check it. From 10 parts I segregated 10 questions we are discussing. All the questions are easy questions only. If you really likes, we have to take the quantum states of an electron in atom, spectrum of helium and alkali atoms, fine structure, hyperfine structure, coupling schemes, Zeeman, Bach and Stark effect, ESR, NMR and X-ray spectrum, molecular spectroscopy, Raman spectra, Frank Condon principle and Born approximation, introduction of the laser, laser rate equation, laser modes and resonances, laser modes of resonators and coherence length. From all the areas I took the questions, from this. In one we have to take as a which one? Positronium atom. Here I have to take the alkali sodium spectrum. Here I have to take the combination of hyperpoint structure and the coupling schemes. From here Zeeman effect I have to take. Here all the spectra I took. Molecular spectroscopy. From rotational spectra I have to take the question. From Raman spectra I have to take the question. From introduction Einstein coefficients I have to take the question. From laser rate equations also I took the question. Laser modes of resonators and coherence length also I took the question. All the 10 parts, each and every 10 questions I explained in this video. So please share my YouTube channel to your friends. This is very useful YouTube channel, right? Once again I am informing you, CSIR and GATE batch will commence from 7th initially we take. But I uploaded, you have to download the app. I uploaded some introduction classes, mathematical physics, classical mechanics and electromagnetic theory, thermodynamics and statistical physics. Now condensed matter physics also available in that. So tomorrow we have to take the origins of the quantum mechanics also. That slide is available in that. Now we will upload all the 9 papers we will upload. You decide whether you like my teaching. You have to purchase this course. This course is very, very well helpful to you. Not only CSIR JL. If you want to become a true teacher means if you know the subject, you able to stand on the platform boldly. How you have to bold in physics, we will make you bit by bit. I will explain little by little. You have to grow, because not a 6 months course. Some people will take only 6 months. They will take some areas, and what are the areas will come. Those areas only those people will teach, and they will take the money. I am not like that. I will cover entire the portion, whatever the portion I am initially giving, the CSIR and GATE portion, entire the portion I will cover. Whole year I will teach. Whole portion is there. That portion is available in the app. Whole year you have to read. Today you are not present, also available in that app also, right? That is the advantage of the online teaching. That app is Quantum Online Academy. You download from the Google Play Store. My numbers are 9908437460, 63032633668. Fees we are keeping some high only. So compared to the Delhi or Hyderabad, some institutes are there. Compared to that institute, the fees is very low fees. You won't think, because 9 papers are there. We have to conduct the exam. That's why we need that much of strength is there. That's why I kept. But after some time, if we finish the mathematical methods of physics, I will make it one course, and I will design for that low fees. But each and every paper I want to take 3,000 rupees for each and every paper. But after finishing that all the recording classes, we have to upload, we have to make one. If you have to week in one paper, you want to take one paper also after some time. Not the, it will take the time. Maybe it will take 2 months, 3 months, whatever it may be. Maybe from 18th onwards, I have to start the mathematical methods of physics. Maybe after March, that mathematics of physics course also will available. That will only for mathematical methods of physics. Each and every paper 3,000 is there. But you have to take the bulk 25,000 fees we have to keep. That fees is very low compared to other institutes and other platforms, because this strength is there. The total above MSc level syllabus, right? The questions also will come, the depthly they are coming. So much of hard work we have to do, that much of the strength is there. That's why we are keeping that one. Don't put other side. Thank you. If you want to negotiate, you have to negotiate also. We will give the concession also. Thank you so much. Thank you for your listening. We will meet with the next video. Please share and subscribe my YouTube channel, that is Quantum Online Academy, to your friends.